Ever pondered how quantum computing could revolutionize the way we process information? In this vast expanse of technological evolution, it's natural to be curious about what's on the horizon. That curiosity, my friends, leads us to the exciting frontier of quantum computing. Quantum computing, a term that might sound as though it's been ripped straight from a science fiction novel, is actually a very real, very powerful technology that's being developed right now. It's the next big step in our technological evolution, a leap that promises to redefine the limits of computation and information processing. But what makes it so special? Enter the fascinating world of qubits. Qubits, or quantum bits, are the fundamental building blocks of quantum computers. They're a bit like the bits in your traditional computer, but with a quantum twist that makes them incredibly powerful. While classical bits can only be in one state at a time, either a 0 or a 1, qubits can exist in multiple states at once. This phenomenon, known as superposition, is what gives quantum computing its immense power and potential. Imagine being able to process vast amounts of information simultaneously, solve complex problems at lightning speed, and even possibly simulate the entire universe. That's the kind of power we're talking about when we talk about quantum computing. It's a technology that holds the potential to completely revolutionize fields like medicine, AI, and cryptography, just to name a few. But, as with any new frontier, there are challenges to be faced and mysteries to be unraveled. The world of quantum computing is not for the faint of heart. It's a realm where the laws of physics as we know them seem to twist and turn in strange, unpredictable ways. But it's also a realm of limitless potential, a new frontier in our quest for knowledge and progress. So, strap in and prepare for a journey into the unknown. As we delve deeper into the realm of quantum computing, we'll explore the strange, fascinating world of qubits, and see just how they could reshape our world. So let's dive deeper into the realm of qubits. What sets a qubit apart from a classical bit that we use in our everyday computers? A question that deserves an answer as we delve deeper into the fascinating world of quantum computing. To understand this, let's first take a step back to the basics. Classical bits, the fundamental units of information in classical computing, operate in a binary fashion. They can represent information as either zeros or ones. It's like a light switch, it can either be on or off, there's no in-between. This binary system forms the backbone of all the modern digital systems we use today. But here's where it gets interesting. Qubits, or quantum bits, the fundamental units of quantum computing, don't play by these rules. They dance to the rhythm of quantum mechanics. In the quantum realm, things can exist in more than one state at the same time. This is a phenomenon called superposition. Superposition allows a qubit to exist not just as a 0 or 1, but as both simultaneously. It's as if our light switch can be on and off at the same time. This might sound like a paradox, a violation of our everyday logic, but in the quantum world it's just another day at the office. This ability of a qubit to be in multiple states at once is what makes it vastly different from a classical bit. It gives qubits the potential to process a vast amount of information in parallel, something that classical bits just can't match. Imagine this, if you have two classical bits, there are 4 possible states, 0, 0, 0, 1, 10, 11, but only one can be used at a time. However, 2 qubits can represent all 4 states simultaneously. Now scale this to hundreds or even thousands of qubits, and you'll start to grasp the immense computational power that quantum computing promises. So, a qubit's ability to be both a 1 and a 0 at the same time is what makes them so powerful and so different from classical bits. It's this quantum leap in computational potential that has the tech world buzzing with excitement. This is the magic of quantum computing, the magic of qubits. But what exactly is this superposition that we keep talking about? Superposition is a fundamental concept in quantum mechanics that allows qubits, the building blocks of quantum computing, to exist in multiple states at once. This is quite a leap from our classical bits, which can only be in one state at a time, a 1 or a 0. Now imagine you're in a room with 2 doors. In the classical world you can only go through one door at a time, but in the quantum realm, thanks to superposition, you can go through both doors simultaneously. It's as mind-boggling as it sounds. Let's break it down further. In classical computing, bits represent either a 1 or a 0, but a qubit, through the magic of superposition, can represent a 1, a 0, or any proportion of both. It's like having a magical coin that, when spun, doesn't just land on heads or tails, but can also land on any point along the edge. This ability of qubits to hold multiple states at once is what gives quantum computing its immense power. With every qubit added, the computational capacity of a quantum computer doesn't just double, it increases exponentially. For instance, 2 qubits can hold 4 states simultaneously, 3 qubits can hold 8, and so on. Superposition is not just about increasing computational power, though. It also allows quantum computers to solve complex problems that are currently out of reach for classical computers. Problems such as factoring large numbers, simulating quantum systems, optimizing complex systems, and many more. But remember, superposition is a delicate state. Any interaction with the outside world can cause a qubit to decohere and lose its superposition, reverting back to a classical state of being either a 1 or a 0. This phenomenon, known as quantum decoherence, is one of the biggest challenges in building practical quantum computers. With superposition, we step into a world where computing isn't just about 1s and 0s anymore. And that, my friends, is the true power of superposition. Have you ever heard of spooky action at a distance? This is not a line from a sci-fi movie, but a term used by Albert Einstein to describe one of the most fascinating phenomena in the quantum world, known as quantum entanglement. In the realm of quantum computing, quantum entanglement is a spooky phenomenon indeed. It's a strange, counterintuitive concept that defies our everyday understanding of how the world works. And yet, it's at the heart of what makes quantum computing so promising. To understand quantum entanglement, let's imagine a pair of qubits that are entangled. This means that the state of one qubit is directly connected to the state of the other, regardless of the distance between them. It's like having 2 entwined dancers spinning in perfect harmony, no matter how far apart they are. Now, here's where it gets even more intriguing. If we were to change the state of one qubit, the state of the other would instantly change as well, irrespective of the distance between them. This happens faster than the speed of light, which is something that Einstein's theory of relativity says should be impossible. But in the quantum realm, the impossible becomes possible. And this is not just a theoretical concept. Quantum entanglement has been proven in numerous experiments, and it's a fundamental principle that quantum computers leverage to process information at a speed and scale that is way beyond the capacity of classical computers. What's even more remarkable is that quantum entanglement can occur not just between 2 qubits, but among multiple qubits. This creates a vast, interconnected network of qubits, all influencing each other instantaneously. This is what gives quantum computers their incredible potential for parallel processing, allowing them to solve complex problems that would take classical computers an impossibly long time to crack. This instantaneous connection or entanglement is what could make quantum computing incredibly fast and efficient. So, the next time you hear about spooky action at a distance, remember it's not just a spooky phenomenon, but a key to unlocking the immense power of quantum computing. So, how could quantum computing change our world? Let's dive into that. Quantum computing, a concept that was once confined to the realm of science fiction, is now knocking on the door of reality. Its potential applications are numerous and far-reaching, promising to revolutionize many sectors. Consider cryptography, the art of writing and solving codes. Today's encryption systems rely heavily on complex mathematical problems that classical computers struggle to solve. However, with quantum computing, we could crack these codes in a heartbeat. But don't worry. It's not all doom and gloom for security. Quantum cryptography could also lead to more secure communication systems, delivering unbreakable codes and ensuring our privacy. In medicine, quantum computing could be a game changer. Imagine being able to simulate and analyze complex biological systems, leading to more effective drugs and treatments. We could understand diseases on a level we've never been able to before, opening doors to a healthier future. Artificial intelligence is another area where quantum computing holds immense promise. AI relies on processing vast amounts of data and making predictions based on patterns. The speed and power of quantum computers could supercharge AI systems, enabling them to learn and adapt faster than ever before. And let's not forget the potential impact on climate modeling, financial modeling, material science, and so much more. The list of possibilities is as vast as the quantum realm itself, but it's important to remember that we're still in the early stages of this quantum revolution. There are challenges to overcome, from developing stable qubits to finding efficient ways to control and measure them. Yet every day, we're making strides, pushing the boundaries of what's possible. Quantum computing isn't just a concept anymore. It's becoming a reality, and it's set to change the world as we know it. As we continue our journey into the quantum realm, We're not just exploring new frontiers of technology, we're reshaping the future. So buckle up because the quantum future is here.